Hey, this is Coach Reeves. Today we're going to solve quadratic equations using square roots. It's going to be a lot of little bitty things that we need to focus on. But first, we're going to take a step back in time to make sure you understand how to simplify a radical. Okay? If I give you the square root of 9, what I need you to notice or remember where this came from. The square root of 9 came from 3 times 3. So everybody knows if I ask you where the square root of 9 is, you'd say it's 3. It's easy. But when we break this down, this was actually 3 times 3. That's how we got the 9. So in the future, we're going to look for pairs. If we have two factors that are paired up, it's going to let us take out one of those 3's. Thus, the answer is the number 3. I need you to remember this concept is we need to be paired up. We need to be paired up to come outside of the radical. Okay? So, look at the worksheet. We have the number 256. Now that's a big number. The first thing I would do with 256, I would check to see if it's a perfect square. That's what you should do in all the problems. If you haven't memorized or you haven't seen them, you need to check. So real quick, we're going to go to my calculator. I'm going to check. So on the calculator, I'm going to take the square root and I'm going to say 256. I'm going to hit enter and it turns out, yes, it's a perfect square. So we're going to go with that. So on our problem, we would say, yes, this is easy, Coach. I did this. This is going to be 16. But what about a number like 50? When you put it in the calculator, you're going to get a decimal 7.1 something. Okay? But what we need to do is we need to simplify a radical that's not a perfect square. So what did this come from? This came from 2 times 25. And the 25 came from 5 times 5. We're looking for pairs. And this is the way I do it. We know I'm goofy by now. But here's the way I say this. If you're paired up, if you have a date, you're allowed to go out. So here's a pair of 5s. We're allowed to go out. The 2 is not paired up. The 2 does not have a date. It has to stay home inside. Some of you guys can relate. All right, so the 5 comes out. The 2 stays home inside. That's how you work that problem. We're looking for pairs. Let's keep going. What if I have a number like 128? Now there's a couple of ways we can do this. That's why I put it up here twice. I'm going to show you 2 different ways to use this. One way we can do this, we can break it down into 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Now what did we say we were looking for? We're looking for pairs. We're looking for pairs. Now this is a little bit over the top. This is a longer problem, but it's okay. Here is a pair of 2's. Here is another pair of 2's. Here is another pair of 2's. This 2 is not paired up. It does not have a mate. It doesn't have a pair. It has to stay home inside. But this, for every pair, let's change colors. This lets me take out a 2. This lets me take out a 2. This lets me take out a 2. 2 times 2 is 4. 4 times 2 is 8. We're multiplying. This is 8 on the outside and a 2 on the inside. Multiply. Every time you have a pair, you can take out a 2 or take out a number and then you multiply them. Okay? Look at this. Now if we use the calculator, we go to our calculator and we say menu and we're going to say number and we're going to ask you to factor. Menu, number, factor. And we're going to put in 128. 128 and we're going to hit enter. And it's going to give me 2 to the 7th power. Let's go back to our piece of paper. It says that this is going to be 2 to the 7th power. To us, that means 1, 2, 3, 4, 5, 6, 7. It's the same thing as this factor tree, but we're just going to stretch it out. And here's a pair, which takes out a 2. Here's a pair, takes out a 2. Here's a pair, takes out a 2. And this guy is not paired up, so it will stay inside. 2 times 2 is 4. 4 times 2 is 8. This is going to leave me with 8 root 2. So you can use your calculator also to find your prime factorization. All right, moving forward. We're going to try to solve an equation now. Now remember, we're going to try to isolate and solve for the variable n. So I need to get this from n squared to the letter n. So to get this down to an n, I'm going to take a square root. The square root of n squared, remember this came from n times n. True? All right, and we're looking for pairs. And so that lets me take out an n. The square root of n squared is n. But if we take the square root to the left, we have to take the square root to the right. And so we're going to say n equals 6. But it also can be what? 6 times 6 is 36. But it also could be what? It could be -6. -6 times -6 is a positive 36. So here's what I'm going to tell you. When you're solving an equation and you're taking the square root of both sides, you will end up with a positive and a negative version. And so sometimes we'll let you write your answer as n equals a positive -6. But you need to remember that you're going to get 2 answers, 2 solutions. Now, I don't know if I said this earlier, but I'm going to tell you right now. Here's a little hint. If this exponent is a 2, then you will have 2 solutions. If that exponent is a 3, then you're going to have 3 solutions. It's how many times you have, or you cross the x-axis, or it's a solution. Now look at this problem. I have r squared equals 8. Now we know our perfect squares. We know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. We know that 8 is not a perfect square. So we're going to take the square root. We're going to take the square root. This is going to give us an r equals what we just talked about. We're going to get a positive and a negative, but we need to break down the square root of 8. 8 can be broken down as this. 2 times 4, 2 times 2. Here is a pair of 2's. So who comes out? The 2 comes out. Who stays home inside? The 2 that's not paired up has to stay home inside. So this would be a 2 on the outside and the 2 that doesn't have a pair. That would be the solution for that equation. All right, let's keep going. Let's try another one. Imaginary numbers. Now, here's the thing. This is the bad news for you. Okay? Your whole life, your math teachers have never told you the truth. Because when you were little, they would tell you that negative numbers didn't exist. And then all of a sudden, when you got older, they said, okay, 3 minus 5 is something called a -2. And you're going, my elementary teachers didn't tell me the truth. All right, so now your high school teachers, we have been telling you, I'm just guilty also, we have always told you that you cannot take the square root of a negative number. Well, today, we're going to take the square root of a negative number. I'm sorry I lied to you, but hey, we couldn't do it then, but now I'm going to teach you. We have the knowledge now, okay? All right, so I'm going to ask you, we're going to take the square root of a negative number, but what you need to memorize is this. You need to put this at the top of your paper or put it somewhere on your paper where you memorize this and use this in your notes. The square root of -1 equals I, an italicized I, which stands for an imaginary number. Sometimes you'll hear us later in the future call it a complex number. But the square root of -1 equals the letter I. So when I work this problem, I'm going to take the square root I'm going to take the square root. The square root of a squared will give me an a. Here, we're going to break this part. We're going to say this is the square root of 4 times negative 1. That's the equivalent of negative 4. But we have the ability, and you're not going to do this every time, but I'm showing you where this is coming from. We're going to split this apart, and we're going to say that a equals the square root of 4 times the square root of negative 1. We have the ability to split a radical if we need to. And now we know we can finish this and we can say, hey, a equals a positive negative. The square root of 4 is 2. And the square root of negative 1 is what we just learned is an I. So when I take the square root of negative 4, I'm going to get a positive negative 2i. I know that it has your head spinning a little bit, so we'll do another one. We're going to take the square root. We're going to take the square root. But here's the thing I want you to understand. Every time that you're going to take the square root of a negative, in your brain you're saying, okay, I need to end up with an I in my answer. They're asking me to take the square root of a negative. I know my answer has to include an I. So the square root of b squared is going to be b equals a positive negative. We know that we're going to get an I somewhere. We know that the negative is going to get us an I. So we're going to break down the 27. The 27 is going to break down as 3 times 9, as 3 times 3. We're looking for pairs now. We've got to have pairs to come out. So here's a pair of 3's. So a 3 gets to come out. But a 3 also stays inside. So what does this give me? This gives me 3 on the outside, the square root of 3 on the inside. But we said that if we take the square root of a negative, we're going to get an I. The question is, where in the answer should we put the I? You need to put the I right in front of the radical. That's where the I belongs. So this would be a positive negative 3i square roots of 3. Okay? You just need to practice, ask questions, but let's keep moving forward. So if I have a problem that looks like this, we need to get r squared by itself. How do we get r squared by itself? We're going to divide by 4. We're going to divide by 4. This was going to cancel. That leaves me with r squared equals 1 over 4. Well, that's not confusing. We're okay with that. Now we're going to solve. We're going to take the square root. We're going to take the square root here. We're going to take the square root. But we have the ability to do this. We have the ability to split the radical like that. That's the same thing as one giant radical or 2 radicals for each part of the fraction. This will give us an r equals a positive negative. What is the square root of 1? 1. What is the square root of 4? 2. So the square root of 1/4 would be 1/2. Got it? Now be careful because we're going to have to deal with this in just a second. Make sure you understand how to deal with the fractions. We're going to review rationalizing the denominator. If you remember, when we had a problem like this, you may have encountered something like this in your geometry class. We're not allowed to leave a radical in the denominator. Okay? So what we do is whatever we have in the denominator, that's what we multiply. We multiply the bottom and the top by this radical. And then we're going to say that the square root of 2 times the square root of 2. We're going to say inside times inside, that's going to equal the square root of 4. And what is the square root of 4? The square root of 4 is the number 2. And then we're going to say outside, and this is inside, so that it stays outside and inside, and we get 3 square roots of 2 over 2. But you have to remember how to rationalize the denominator. Some of you may have had a bad experience in geometry, I don't know, but we still have to rationalize the denominator. Okay? So whenever you have a radical at the bottom, you multiply by that same radical and it will clear it out. And we're going to need this for the next problem. All right, step 1 on this problem. We're going to move the 5 to the other side because we want to try to isolate and solve for the variable n. So we're going to go plus 5, plus 5. This is going to give me 3n squared equals a negative 28. Let me bump this up a little bit so it doesn't get too low. We're going to divide by 3. We're going to divide by 3. I'm looking at n squared equals a negative 28 over 3. We need to take the square root. So we take the square root. Shouldn't do that. We take the square root. We take the square root. We split it because it's a fraction. We get n equals a positive negative square root of 28. Now we're going to have problems with this, so we're going to simplify the 28 real quick. We're going to come over here and we're going to break down our 28. That's going to be 2 times 14. That's going to be 2 times 7. Here's a pair. Here's a pair of 2's. I get to take out a 2, but the 7 has to stay inside. So that's going to give me 2 square roots of 7. But remember what we said. That negative is going to get us an I. We're going to get an I. So where do we put the I? We put the I in front of the radical sign. Over the square root of 3. Now here's the question. We just talked about it, but are we allowed to leave a radical in the denominator? No, we're not. But the thing is, how do we get rid of this radical? To get rid of a radical in the denominator, we multiply the bottom times the square root of 3, the top times the square root of 3. What's going to happen is I get n equals a positive negative. A square root of 3 times the square root of 3 is going to give us the square root of 9. What does the square root of 9 equal? The square root of 9 equals 3. That's the very first thing we talked about. And then we're going to say the 2i is outside of the radical. So this outside part stays outside. This is going to stay outside as 2i. But what is the square root of square root of 7 times the square root of 3? Inside times inside stays inside. Look what we did. Inside times inside went inside. Inside, inside stays inside. That's going to give me a 21. That'll give me 2i square roots of 21. Remember, now this is going to be a positive negative. The question is, and you have to remember what the answer is, can you reduce something that is inside or underneath the radical symbol and something that is not? This is inside, this is outside. You cannot reduce that fraction. That would be your final answer. Okay? Now there's a lot of things we just talked about. We talked about simplifying a radical. We talked about solving a radical equation to where you're going to end up with a positive negative. Okay? We introduced something called an I, an imaginary number. And that's going to bother you a little bit, and you're going to have to practice that. And then we talked about rationalizing a denominator. How do you do it? How do you handle a problem if there's a radical at the bottom? A lot of different things on this worksheet. This is a big worksheet. You need to work and you need to practice, and it's okay to get stuck. You just need to ask questions and let us help you. Please show up in the Zoom. Okay? This 6 weeks is going to be a tough 6 weeks because there's some tough material, plus it's really short and it's going to happen really fast. So please communicate with us and let us know where we can help you. Good luck.